Alright, so here we go.
Oh, really?
First things first. How do we even know when we see an equation like this that it is an ellipse and not a circle and not a parabola? Because on test day, you're just going to be given a list of equations and told to find all the pertinent information. So that's like center and vertices and all that stuff. It's not going to say, here's an ellipse. So how are you going to know when you look at this equation that it is not a parabola? You have two squared terms. Parabolas are the easiest to identify. Parabolas only have one squared term. If you have two squared terms, you are not a parabola. Now, how do I know this is an ellipse and not a circle, Patty?
Look at the coefficients.
Exactly.
They only common factors.
If they don't match, if these coefficients don't match, then it is not a circle, it's an ellipse. Now, I want that ellipse, that equation, to look like that equation. So clearly I'm going to have to complete the square, right? Not? Yes, Mrs. Ford, you're going to complete the square. So what I'm going to do is, I'm going to take my x terms, and I'm going to group them together and factor out, in this case, the 4. So I am getting ready to complete the square. So I'm going to take my 2x terms, pull out the 4, and I'm leaving a blank because I'm going to complete the square. Now I'm going to do exactly the same thing with my y's, only I'll pull out a 9. And that 4 is going to the other side. So I've taken my equation, Fletcher, what are you doing? Not acceptable behavior. This is a no phone zone. 24/7, no phone zone, unless you specifically ask permission. All right, let's focus on the ellipse now. Everybody with me so far? Okay, now I'm going to complete the square. Be careful. You do it just like you always do it. Half of 2 is 1, squared is 1. But that 1 is inside of parentheses, getting times by 4. So really, I'm going to be adding 4. Same thing here. Half of 4 is 2, squared is 4. But that 4 is really a 36. Now, this should be a perfect square. That's why we did what we did. This is x minus 1. And this is a perfect square, y plus 2. And it adds up to 36. Now we have one more thing to do to make our equation look like that one over there. What do we have to do to it? Divide by 36. And lo and behold, when we divide by 36, everything works out nicely. And we end up with x minus 1 squared over 9 plus y plus 2 squared over 4 equals 1. Everybody okay with that? Yep. Then we're ready to go. Here we go. I'm going to erase part of this. Everybody's got the equation, right? We're good on the equation? All right, so take a moment, see if you can find everything you're supposed to find. So that means find your center, find your vertices, find your foci. O and the major and the minor axis, the length of the major and the minor axis. So So see if you can find that. Your center, your vertices, your foci, and the lengths of your major and minor axes. There's cold air blowing in this room.
It's freezing.
Do we sit at the same time?
I
Every day?
I don't know why that is. Because then it seems to get warm. But Chloe, did you have a pass? Did you have a pass?
I didn't come in.
Honey, you weren't here during the prayer.
Kelvin told me.
Yeah, I brought in a pass though.
No, yeah, but,
I was sitting right over there.
oh, you were sitting in a different spot? Okay.
Yeah.
All right, we have our center. Where's our center? 1, -2, all right. Where are our vertices?
4, -2.
Sideways 3, so 4, -2, yep, and the other one is? -2, -2, and then up and down?
1, 0.
So 1, 0, and
1, -4.
1, -4, all right, good, those are our vertices. How long's our major axis then?
6,
And our minor?
4.
Good. Our foci are somewhere on the major axis. How far is it in this problem from the center to the focus? In this problem, center to focus is square root of 5. So what are going to be the coordinates of my focal points here? What are they going to be?
1 plus root 5.
1 plus root 5, comma, and
1 minus root 5. -2.
everybody good? Alright, let's practice one more, putting it in standard form, and then we'll do something different.
Is the foci always on the longer one?
Yep, always on the major axis. Alright, here's our ellipse. And again, we know it's an ellipse because we got 2 squared terms. They're added together, but their coefficients are different. So it's got to be an ellipse. And we want to get it into standard form so that we can find all of that stuff. So here we go. Remember how we do this? We put our x terms together and pull out the coefficients. So x squared plus 4x. And then we leave a little blank there because we know we're going to be completing the square, right? All right, so then we go to our y's, same thing, only we're going to take out a 25. So that'll be y squared minus 6y. Move the 141 to the other side and leave 2 blanks, because we're going to add 2 things on this side, we got to add 2 things on that side. Does that look all right to everybody? Gotta be able to do this by yourselves. All right, let's complete the square. Half of 4 is 2 squared is 4, but that 4 is really a 16. Half of 6 is 3 squared is 9, but the 9 is really a 225. Everybody okay? So now we got 4 times x plus 2 squared plus 25 times y minus 3 squared. Remember, these are perfect squares. That's how you made them. That's why you did what you did. And what's it going to equal over here? Is that 100?
Yeah.
So we're almost done. Now we're going to divide. So we have x plus 2 squared over 25, y minus 3 squared over 4 equal to 1, because we divided everything by 100. No.
It doesn't always just equal here too.
No. It does a lot, especially when I'm making them up, but no. And in fact, these don't have to be perfect squares. I'm making them perfect squares because it makes it a lot easier to plot, but they don't have to be. There's some in your homework that will have like a 7 down here, which means you're going to go right and left root 7. All right, so here we go. Where's our center? Our center is at negative 2, 3. I'm going sideways 5. And up and down 2. All right. Take a look at my vertices, see if they match yours. My major axis is how long? 10. And my minor axis is 4. My foci are on the major axis. Right? How far on the major axis? What's the distance from the center to the focus in this ellipse? Root 21. So what are the coordinates of these points right here? I'm going back and forth, root 21. So those points would be negative 2 plus, oh, not this one, negative 2 plus root 21, comma 3. Yep, that's it. Are we ellipse masters? All right, now we're going to go backwards. So I'm going to give you some information, like some of these points, and you're going to build the equation. All right, so let's see how we do with that. So we'll start with kind of an easy one to get warmed up here. First example. I'm going to tell you it's an ellipse. I'm going to write the equation of an ellipse. And I'm going to tell you that the vertices are 2, 2, negative 4, 2, negative 1, 4, and negative 1, 0. Those are the vertices of the ellipse. That's all I'm going to tell you. And you're going to write the equation. Okay? Now, remember, what you are shooting for is something that looks like this, right? That's our goal. We want an equation. I erased the last one here, but don't we want an equation that's set up like this? So let's look at what we know and see if we can figure out the numbers that have to go in the equation there. So we have a vertex at 2, 2, and a vertex at negative 4, 2, and negative 1, 4, and negative 1, 0. So your ellipse looks like this.
The center for the x have to be negative 1.
Wouldn't the center for the x have to be negative 1? What do you think about that? And what about the center for the y? Wouldn't it have to be 2? Now think about it. Aren't your axes going to cross right there at the center? Isn't this the line where y is 2? And this is the line where x is negative 1? Now you could also do midpoint, right? Won't the center be the midpoint of these or these? So if you'd rather do midpoint, you can. Either way, the center has got to be negative 1, 2, which means your equation is going to be x plus 1, y minus 2. Now we need to fill in our denominators. All right, so let's think about what's going on here. If you were plotting this, you would start at your center and you'd go forward and backward how many? How many am I going forward and backward here? 3. So my x radius is 3, which means under x has to be a 9. Remember, square root of that tells you how far back and forth to go. What about y? Well, I seem to be going up and down 2, which means under here has to be a 9. That's it. That's all there is to it. That was easy. Peyton?
So it has to tell you what you're finding when it gives you the points, like what?
Yep.
Okay.
Yep, you have to know what shape you're after, indeed. Yeah. Now, if I had used the word vertices and you plotted those points, then clearly it's an ellipse. But if you're just given 4 random points, you need to know what you're looking for. We've got some funky shapes out there in the world. All right, let's try another one. Maybe this one's not quite as easy. Another ellipse. And I'm going to tell you that the major axis has endpoints at 7, negative 1, and negative 1, negative 1. And the foci are 3 plus or minus root 7, comma, negative 1. So that's the given. We have an ellipse. We have an ellipse. And its major axis has endpoints at 7, negative 1, and negative 1, negative 1. So I don't know exactly what the thing looks like, but it's stretched this way because that's the major axis, right? And the foci are at 3 plus root 7, comma, negative 1, and 3 minus root 7, comma, negative 1. So that's the given information. And this is what we are shooting for. Is that you on again? All right, can we figure out the numbers? Do we have enough information? How can we figure this out? Can we find our center? Yep. Yeah, that's pretty easy. It's gonna be right smack dab in the middle of these two, right? So what's the average of -1 plus 7? Or -1 and 7? -1 plus 7 is 3 divided by, or 6 divided by 2 is 3. So my center is at the point 3, -1. Which means x plus 3y minus, or no, it was 3 -1. So x minus 3y plus 1. Do I know anything else? I know these vertices. So here's my center. How far left and right did I count? 4. Okay, so I went left and right, that's x direction, 4. So under x must be a 16. Right?
Yep.
Now I have no idea how far up and down I went because they didn't give me those points. But what do I know? Antonia?
You know that root 7 is
I know
their,
that distance
yeah,
is root 7. And how do I find that distance from center to focus?
16 minus whatever is y.
It's going to be the square root of 16 minus, I'll just call it n for the time being. The square root of 16 minus n has to be the square root of 7.
Yep.
Which means 16 minus n has to be 7. So n has to be 9. That number has to be 9. So I had to kind of wiggle my way through that, figure it out.
Here you go.
Let's try one more. Any question about that one? Try one more. Alright, this time we have minor endpoints at 2, 8 and -6, 8. So this is the minor axis. And we have foci at -2, 8 plus or minus 2, 5. So we kind of have the same sort of given, a little bit different, the minor axis this time. So let's see if you can figure this out. looks like this, because this is my minor axis now. So my foci are up here. They're on the major axis. So all right. What do you think? Do you know anything? Do you feel anything in on that equation? The what? What's our center?
Negative 2, 8.
Negative 2 comma 8. Everybody in agreement? That's the center? Alright, well that helps because then I've got x plus 2 and y minus 8. That's good. Good.
No, y is over 16.
We know y is over 16. How do we know y is over 16?
Because the distance from the vertex to the side is 4. So you square that.
Okay, which way am I going?
Horizontally. 4.
I'm going horizontally.
Yeah.
So where should that 16 be? If I'm going 4 units, then you're right, you are. You're going 4 units left and right. Where should that 16 be?
Under x.
Under x. That's the x radius. I'm going, my x radius is 4. I'm going 4 units in the x direction, which means under x is 16.
Oh, that makes this fun.
All right, now what?
16 minus whatever it is.
Okay, we got to be really careful. Which denominator is going to be bigger? The y. So it's not going to be 16 minus whatever. It's going to be whatever minus 16.
Oh, okay.
Does that make sense to everybody?
Yeah.
It's always the big one minus the little one. Otherwise, you're going to be imaginary because you're taking the square root. So I know the square root of whatever that y denominator is minus 16 is going to be the square root of 20. 2 root 5. So n minus 16 has to be 20, so n must be 36. All right, now did you follow all that? There was some little kind of details we had to pay attention to. You got it?
Yep.
Okay. Well, we have one conic section left to talk about. Oh, wait. I did not give you the definition of the ellipse. So I'll give you the definition of the ellipse and the definition of the hyperbola together. So let's review. What's the definition of a circle? Set of points in a plane, equidistant from a given point. No, not a circle. Circle, equidistant from a given point. Period. Stop. What about a parabola? Set of points in a plane, equidistant from a given point in a given line. Ellipse. Set of points in a plane. The sum of these distances from two fixed points is constant. Now, what do you think those two fixed points are?
The vertices.
No, not the vertices. There's 4 of those. What are the two fixed points? The foci. Yep, the foci. A hyperbola is word for word. So I'm just going to use quote marks. It is word for word the same definition, except instead of the sum being constant, it's the difference. that's constant. So that word becomes this word. Otherwise, the definitions are identical. The ellipse is a set of points in a plane, the sum of whose distances from two fixed points is constant. The hyperbola is the set of points in a plane, the difference of whose distances from two fixed points is constant. Okay? If we take two sugar cones and set them tip to tip, so like this one I'm holding it, I've got my ice cream and I'm eating my ice cream. The other one's upside down. So they're tip to tip. You just slice down through them. You get a shape that looks like this. That's a hyperbola. Now, the only difference between the equation of an ellipse, by the way, remember we looked at one like this. That was the equation of an ellipse, right? The only difference in the equation of the hyperbola is right there in the definition. So instead of that being a plus, that's going to be a minus. Now you got a hyperbola. Whole different set of points. So how are we going to recognize the equation of a hyperbola? X squared minus y squared. Or vice versa. It can be y squared minus x squared, and we'll talk about what difference that makes.
Could we get like a whole bunch of different variables like we did when for the more complicated?
Yep. Yep.
How are we supposed to recognize that? So it's just like in the beginning, it's just like where it says 4x squared plus
Yep.
5y.
We're going to do that. We're going to go through that, but basically it's the same procedure, and you end up with an equation that looks like, you know, this.
Okay.
All right, so let's take a look. Let's do this real simple little hyperbola here. Do this real simple one. Let's get the basics down before we start doing all the completing the square and all that stuff. Guess what the center of that guy is? 0, 0. So he's centered right here at the origin. Now, if he were an ellipse, what would this 25 tell you? Go sideways 5. We're going to do that. Okay, here we are. What would that 9 tell me?
3 up and down.
I'm going to do that too. Now, here's the difference. So far, I have done everything exactly the same. Here's the difference. You know when it was an ellipse, you just connected those with a nice little oval? Now I want you to connect them with a rectangle. I want you to draw a rectangle. Oh, I remember this, somebody says. We're going to draw a rectangle. So it's the same points as you would do with an ellipse, but you're going to draw a rectangle through them instead of an oval. Then, I want you to take your pencil and I want you to draw in the diagonals of the rectangle. And traditionally, we use dashed lines because these guys are going to be the asymptotes of the hyperbola. So, out 5, up 3, draw a box, put in the diagonals. Now I'm going to draw my hyperbola, and from the setup, you can see I could have a hyperbola up and down, framed by these asymptotes, or I could have a hyperbola sideways framed by the asymptotes, right? The direction of the hyperbola is whatever letter comes first in the equation. I don't care how big these numbers are, not important. Whatever letter comes first, that's the direction of the hyperbola. So this hyperbola opens left and right. It opens in the x direction. and it is contained by those asymptotes. So as you draw your hyperbola, you're heading closer and closer to those asymptotes. If I had switched these around, everything would stay exactly the same, except instead of drawing that hyperbola, I would have drawn this one. Does that make sense to you? Those are called conjugate hyperbolas. They're the same asymptotes, you just draw the different set. These 2 points right here are called the vertices. Those are called the vertices of the hyperbola. How many vertices does a hyperbola have? 2. Now you're saying, well, Mrs. Ford, what are these points? Well, those points are important because I needed them to draw the box, right? But they're not part of the curve. Would you agree with me? They're not points on the curve. This axis right here is called the conjugate axis. And so these points would be the endpoints of the conjugate axis. And the length of your conjugate axis is 6. This axis that joins the actual vertices is called the transverse axis. And that word makes sense because transverse, across the vertices, joins the vertices, transverse axis. And again, whether you are transverse or conjugate has nothing to do with your length. It so happens in this example that the transverse axis is 10 and the conjugate axis is 6, but it could be the other way around. Transverse means you join the vertices. Conjugate means you're the other side of the box. On that transverse axis somewhere are your foci. Notice they are inside the branches of the curve, just like with the parabola. If you think of this as like a parabola, there's the focus. They're inside the curve. The distance from the center to the focus. It's from the center. The distance from the center to the focus. Anybody want to take a wild guess? How do you find it? What'd you say, Wyatt? Yeah, exactly. It's the square root of, in our problem, 25 plus 9. Now, I want you to think about this for a second, kids. What would happen if you subtracted 25 minus 9? You get 16, you get 4, right? What would happen if the foci were only 4 units away from the center? They wouldn't work. They wouldn't be inside the curve. So you got to add. You got to go past the vertices. So you got to add these 2 numbers, which means these foci start at the center and back up root 34. So what are the coordinates of this focus? I am backing up root 34 from the origin. Negative root 34, comma, 0. And this one would be positive root 34, comma, 0. You're thinking, oh my gosh, my head's going to explode. No, we have one more thing. One more thing. So now we need to find the equations of the asymptotes. Now that's easy. Because the asymptotes are lines, and you've known how to do lines since about the 7th grade. Y equals mx plus b. What do we need to know? We need to know the slope and we need to know a point, right? So I want you to look at this asymptote right here. We'll start with this one. Do we know any points on that asymptote? The center. The center will always be on your asymptotes, right? Because those asymptotes are going to cross at the center. So you're always going to have your point. This one happens to be 0, 0, but it doesn't have to be. We can move these things around. But this one is 0, 0. So my point is 0, 0. Now I need my slope. Now think about it. When you built this box, didn't you do some counting up and over?
Yep.
So you counted up 3 and over 5. So what's the slope of that asymptote? 3/5. So now we can write our equation, however you want to do it. I'm point sloping. So y equals 3/5 x. Is that one? Now what about this one? It's going to have exactly the same point. Would you agree?
Yeah.
It's going to go through the center. They cross at the center, so they both have the center. What about the slope of that one now? It went up 3 and left 5. So wouldn't that slope be negative 3/5? In fact, won't the slopes always just be opposites of each other? Now, not opposite reciprocals. Don't get carried away. They're just opposite. One slope will be 2, and the other one will be negative 2. One slope will be 5/7. The other's negative 5/7 always. So the equation of this asymptote is y equals negative 3/5 x. You can now do your 8.0, 8.1, and 8.2 homework, and you can actually start your 8.3 homework. So since you have, okay, what's today, Wednesday? I don't see you tomorrow, Friday, Saturday, or Sunday, unless we get incredibly lucky. You have 4 days. Okay, 4 days. You need to be getting going on this homework or you are going to be swamped next week.